Hello, and welcome to Let's Make a Top-Down Shooter. This video is about chaining our laser beam onto a few extra targets. And a special thanks to all my supporters. Your support is what makes this worth doing. Before we make changes to the laser beam gameplay ability, some of the changes are necessitating how we go about creating our Niagara system. The short of it is that we are now going to use an actor. I'm going to call this BP Laser Beam. And all this is a Niagara component. We'll make that the root. This will be our laser beam. And you can see it there. So we're effectively doing this because even though we were able to spawn a Niagara system attached, if you spawn a Niagara system and then you want to attach it later, it doesn't really work. So in this case, we can attach this actor instead of the Niagara system itself, and it ends up working out well. So with that, we'll go back into our laser beam. Going to make a bunch of changes to this. First, I'm going to add a new function called spawn systems. This will accept a count. And it's going to be a for loop from 1 to that count. We're going to spawn our BP laser beam. I'm going to change this laser beam we used previously. I'm going to call it laser beams and make it an array. It'll complain. We'll just change the variable type and deal with it after. So for that, we're going to drag this out and just add each one to this array. Right, I do need to change the type as well to our BP version, which it will also complain about. And if you ever go to spawn an actor like this, it will complain. It's basically, well, I mean, there's a number of errors because of the other changes, but this right here, it's because the transform does not have any values set, but if you just split it, it now has values set for those three things, and it's all good. It's still not compiling fully, but this thing is fine now. All right, so back in our event graph, we can get rid of our destroy component here. We're going to do a for each loop. Pop this down a little lower. And all we're doing here is destroy actor. So now it is an actor. So that's our cleanup. Up here, after we've committed, I'm going to add our call to spawn systems. Move all this stuff out of the way. The count for spawn systems will be based on a variable we've set here. We'll call this max chains. This will just be an integer, not an array. And we'll set the initial value to, recompile it, there we go, to 2. So the number of chains is how many chains there are after we've hit our first target. So this means we want chains plus 1 for our number of systems. So now that we have spawned all our systems, we can get rid of this spawn here, the set value. We're going to be calling set actor location. We're going to get our laser beams array. The first entry is from the player to the end target location. So the actor we're setting is the first laser beam. We're going to split this as usual so that we can set our Z value at 50. And we want to use the character location. And we do that so we can grab this again. And we're calling attach actor to component. So very similar to before, we'll use the mesh of the character as the component it's being attached to. In this case, we want our location rule to be keep world. And the rest is fine as it was. In our fire function, when we're doing our line trace, when there is a hit actor, we're going to take that, we're going to cast it to BP enemy character. If that is successful, then we will promote to a local variable our hit enemy. Again, like before, we need to switch this to get our first laser beam. We're going to create a new variable. This will be our hit enemies. This will be an array for keeping track of all the enemies we've hit this tick, effectively. And given that, we want to clear it. As a reminder, this fire function will be called basically every tick. We can then run a sequence. And in the case where our hit enemy is valid, we're going to call a function called chain. This will accept the hit enemy, so we can just call it hit enemy again. And then whether hit enemy was valid or not, we are going to iterate through our list of laser beams. We're going to do this a for loop instead of a for each loop. That's effectively so that we can get the index. And in this case, we want to go from 1 to our length minus 1. And the intent here is to basically set the visibility of each laser beam. So I'm going to pull that out again. We want to get a copy. We're going to call set visibility on the Niagara system. The index will be that. So again, it's skipping the first one at 0, and then it's going to the last laser beam in the array. So because we set our max chains to 2, the laser beam length will be 3, which makes it 2 here, so it'll effectively be 1 and 2 is what the loop will include. And the point here is so that as long as this index is less than or equal to our hit enemy's length, it will be visible. So again, we're looping through the 2 laser beams that are for chaining, and as long as that index is less than the hit enemy length, then it's visible. The reason we're doing it this way instead of code that would look slightly easier to read, where you could just set everything to false for visibility, and then if it's valid, you'd set it to true. That doesn't work because then you're effectively turning the visible state on and off, or off and on, every tick, and Unreal just doesn't like that. All right, so inside of our quite large chain function, this will be a recursive function. It will be calling itself, so we need to have something that determines whether or when it should stop. So what that will be is our hit enemies, which is going to start at 0. We're getting the length. As long as that length is less than our max chains value, we will continue. Once that's no longer true, it will just return from the false condition and end the recursion. So then the first thing we're going to do in here is take our hit enemies, and we're going to add the hit enemy value here. So with that hit enemy's location, we're going to sphere overlap. So we'll take our hit enemy, get the actor location. In this case, I'm not going to set it up 50 higher because there's no need. You can just play with the radius value otherwise. Now we're going to set this to 500. The object types, as usual, is just pawn, and the class filter will be our enemy character. And the actors to ignore is all the ones that are already in the list. So even though there's a actor class filter, the output of this is actors, not enemy characters. So we're going to promote that to a local hit enemies array. And then as long as that is not empty, we're going to take our laser beams array, we're going to get an entry, and the index of the entry we're getting is the hit enemy's current length. The first time we go into this function, hit enemies at this point will be 1, so it's getting the second laser beam. Again, the second laser beam is the first chain, and we're just going to promote this to a local variable. We'll call it local laser beam. And like before, we're going to use that to set the actor location. I'm going to split this so we can set the Z value as 50. We're using our hit enemy. This will be what it's attached to, so we want to get our actor location. Split that. So that we can then attach actor to component. The component being our hit enemy's mesh. Again, keep world. And with our laser beam attached to that hit enemy, we're then going to get our local hit enemies. We're just going to get the first entry so that it is somewhat consistent. We're going to cast that to our BP enemy character. So that we can take our local laser beam, set the Niagara variable by string vector. This will be our end loc. And the location will be the enemy character with a Z of 50. And lastly, we call chain recursively, sending along this new hit enemy. All right, let's just go over that again. So in fire, we did what we did before. Basically, when it hits something, it will store the end location, make that the end of the first beam. If there is a hit actor, it will save it as the hit enemy. We're clearing out our hit enemies array, and then as long as the hit enemy is valid, we're calling chain on it. Inside of chain, we're just doing some check for the recursion, adding the hit enemy to our array. We're overlapping at the location of that hit enemy to find other enemy characters. As long as it hits some actors or some enemy characters that were not part of hit enemies. We get the first chain laser beam so that we can set that attach location to that hit enemy and set the end location to the first enemy that was in the overlap sphere. We then call chain again, so chain will go through. This will be the second time chain is going. Second time, this is still valid, adds it to this list, does the same stuff. And then over here, because our hit enemy's length just went up by 1, it will get the second chain laser beam, which is the third laser beam, and then do all the same stuff. In the end here, even if there's another entry, it will call chain again. But at that point, our branch here will be false, and it'll leave the recursion. We're using this logic to set the visibility of each beam so that it's not constantly flickering on and off. All right, so we go in here, hold down E, still working the same way as it was. We'll go in here, find some enemies. And there you go. Now, when you just hold it, you can see it does occasionally change. That's because it's getting that first entry of the array, and its sphere overlap is consistent some of the time, but not all of the time. Thanks for watching. If you liked the video and would like to see more, you know what to do. And if you would like to support this channel, watch these videos 2 weeks early, or just want to download the project files, you can do so through my Patreon linked below.